We will have a look at the notion of streams, upon which all of Java's input and output is based. Streams are flows of data from a source to a destination. The source can write to a stream on one end, and the destination can read off the stream on the other end. As ever so often, streams are objects. Different types of streams are implemented in different classes, and those differ, for example, in what direction they point, but also what source or destination are connected. For instance, files, network sockets, keyboard input, etc. Some streams even internally use other, simpler ones in order to provide a more high-level interface. Many of these classes are provided as part of the standard library and live in the package java.io. In the standard library, streams are modeled in an object-oriented way. More precisely, in Java there are classes representing one or the other end of a stream. In input streams, our program takes the perspective of the destination, which means that we can read off data from an input stream. And similarly, an output stream allows you to take the role of the data source, which means that you can write onto the stream. Streams can also differ in what kind of data can be written to them. The most basic ones are implemented in InputStream or OutputStream classes, and those are byte-based. That means that the basic unit of data on the stream are in fact bytes, meaning 8-bit blocks. For example, the InputStream class offers a method called read, takes no parameters, and it returns an integer. And that will return the next byte of data from the input stream. You have already used input and output streams without knowing it, of course. Very prominent ones are the so-called standard streams, standard input, standard output, and standard error. These are accessed via system.in, system.out, or system.r. And in fact, system.in is an object of type input stream, so it allows you to read individual bytes from it. And similarly, system.out is an object of type output stream, so you can write individual bytes to it. In fact, system.out as well as system.r are objects of a specialized stream type, namely print stream, that provides a few convenience methods called print as well as print line for all basic data types. So in fact, when you do system.out.println and give it a string, what you actually do is you call this public method println with a string parameter on the object system.out, which is a static object of type printstream defined as an attribute of the class java.lang.system. Right, so the basic types of streams are input and output streams, and these are based on bytes. But there are more higher level ones. For example, Java.io reader and Java.io writer are character based. This means the basic unit of information is a character encoded in 16-bit Unicode. So in fact, each individual datum consists of 16 bits, and it's interpreted as a character according to the Unicode standard, which translates blocks of 16 bits into characters. And since 16 bits allow 2 to the 16 many different characters, that means that there are lots of characters which are represented in this standard translation. Not only the Western alphanumeric characters, A to Z, upper and lowercase, and all the digits, but also, for example, pi or Chinese characters or even emojis. Whenever you're looking at a reader object, it is character based, and that means you can read a Unicode encoded character of that. The method to do that is still called read, and the signature is, well, it's public, and it returns an integer and takes no parameters. It's a bit funny that it reads integers, but that is because character is in fact syntactic sugar for a 16-bit integer. So what you can do is you can cast the return type into a character. You can, for example, say character C is equal to jar read. That would be fine. Even higher level streams are possible and supported via the standard library. Just as data streams support input-output of primitive data types, object streams support I/O of whole objects. For this to work, Java needs to know how to flatten your object into a streamable piece of data. And this works as long as the object that you want to write onto the stream belongs to a class that implements the serializable interface. The syntax for the object input stream is, as you would expect, there's a method called readObject and it returns an object, which of course you can cast into more specific classes in your application. Right, a short summary about Java I/O. All of Java's input-output is based on streams. Usually you have the basic types InputStream and OutputStream. So whenever you have a class derived from that, it's usually called something stream and it's based on bytes. Whereas higher level stream types are often called readers and writers, and that indicates that they are based on characters. Many derived types of streams can be found inside java.io. This includes predefined streams for file access, network access, etc. Some of them internally use other more basic stream types in order to provide a more convenient higher level access to a certain stream.